We're looking at our 7-3 quiz about complex fractions. For number 1 here, we already have a fraction over a fraction, so all we have to do is multiply the numerator by the reciprocal of the denominator. So we'd have our x over 9, multiply that by x plus 7 over 4. Not much to do here other than to set that up as x times x plus 7, and then we can go ahead and multiply the 4 by the 9 and get 36, and that's really about all we're going to do for that one. Alright, for the second one, it's going to be very similar. We would take the numerator, the 7 over y, multiply that by the reciprocal of the denominator, so we flip this 4 over y plus 5 over, so we have y plus 5 over 4. Now, some people are going to be very tempted to do some things that they shouldn't do. For example, like try to cancel out these y's. The thing is, this y here is not really a y, it's a part of a y plus 5. Maybe make that look a little bit more like 5. And that's all that is. So we have the 7 is multiplying the y plus 5, and the 4 is multiplying the y, but nothing is going to cancel out there. Again, the y on top is not just a y, it's 5 more than y, so we can't cancel out with the y on the bottom. So make sure that you don't make that mistake. For the third problem here, we can't just jump right in and do like we had been doing. We have to go ahead and add those together. And so again, I'm going to look at probably using that first method where I write the numerator as a single fraction and also go ahead and write the denominator as a single fraction. In this case, the LCD for the numerator would be x. So the 2 has it, the 4 needs it. So we multiply the 4 by x over x. That ends up giving us 4x over x plus the 2 over x. So that would be 4x plus 2 over x. And keep in mind we may want to factor out that common factor of 2 there. In the denominator, the LCD would be 8. The 1/8 has it. The x over 4 is almost there. We just have to double it. So we get a 2x over 8 plus 1 over 8. So we get 2x plus 1 over 8. Again, notice I'd mentioned maybe taking the 2 out of the 4x plus 2. By doing that, that would give us a 2x plus 1. So if I do that down here, take the 2 out of the 4x plus 2, we get 2x plus 1, and that's over an x. If I flip over the denominator, we get 8 over 2x plus 1. So now that we have that 2x plus 1 in the numerator and in the denominator, those will cancel out. In the numerator, we'd get 2 times 8, so that would be 16, and then the denominator would just be the x. So it would look like that when we're done with it. For number 4 here, I would probably lean towards our second method, so identifying the LCD for both of these. The LCD for both the numerator and the denominator would be PQ. So again, what we do is we multiply the big numerator by PQ and the denominator by PQ. Again, that's what makes that okay. And what we end up with over here is a 36p squared minus 49q squared. So clean that up a little bit. So minus the 49q squared. And in the denominator, we end up with, let's see, with the 6 over q, the q's would cancel, so we have a 6p. And the 7 over p, the p's would cancel, so we have minus a 7q. Make sure that you don't stop here, because the numerator, notice that's that difference of squares factoring pattern. So I'm always saying how you have to be able to catch that, because it's going to sneak up on you. So 6p minus 7q times 6p plus 7q, and our denominator was 6p minus 7q, And that will then, of course, cancel out with the 6p minus 7q that we already have. And so the whole thing really just ends up being 6p plus 7q. So make sure with that one, of course, too, that you mind your p's and q's. Kind of easy to get confused with those. So just be careful. Alright, and for number 5 here, we've got the negative exponents. We're going to have to simplify that. Again, remember we can't just drop those to the denominator. We have to make our own little fractions in there. So 1 over x cubed plus 1 over y cubed for the numerator. And then in the denominator it'd be 1 over x plus 1 over y. Again, trying to decide which method to use here. I could see using either one, either adding those together or multiplying both by the LCD of the entire thing. I think I might lean a little towards multiplying by the LCD for both. And with that x cubed, y cubed, that would be the LCD there. You can remember the numerator, denominator really in parentheses. So multiplying both by x cubed, y cubed. So on the numerator, that's going to be fairly simple. We're going to get a lot of things to cancel out. So we're going to get y cubed plus x cubed when that's all said and done. So that's our numerator. In the denominator, again, you've got to be a little bit more careful. When you multiply the 1 over x by x cubed, y cubed, we still have an x squared. So we'd end up with x squared y cubed. And we would end up with an x cubed y squared. Now, in the denominator, we do have a common factor that we could take out of each of those. We could take out an x squared, y squared. I don't see that it would... well, actually, let's see. If we take a look at this, if I take an x squared, y squared out of the denominator, let me put the denominator here, so x squared, y squared. And that denominator would end up being a y plus x or x plus y. Either way, again, does not make a difference. Now, what I'm noticing about the numerator, if you see here, y cubed plus x cubed, so that's actually a sum of cubes, and if I go to factor that, my first factor for that will be y plus x. Now I know I'm again dipping into some stuff that we talked about a while ago, but again, this factoring, very important that we stick with it. Now, I do need to figure out my other factor, but that would end up being a y squared plus xy, or yx, doesn't really matter, the order, plus an x squared. So the x plus y, or y plus x, again, whichever way you want to say that, ends up canceling out, and so we actually end up with y squared plus xy plus x squared, which does not factor, by the way, over an x squared, y squared. And so that's what we actually end up with. So a little tricky there. They snuck in a sum of cubes. And again, it was important that we factored that because that way we saw that those y plus x's canceled out. So if we had left it like this, then we're in trouble because we missed a common factor that we could cancel. So you be careful with that. Alright, and then last one we'll do here, number 6. Again, starting with writing this with positive exponents. So 1 over x squared. Again, the tricky thing with the 49 there is the 49 stays on top. And again, that's because the 49 does not have that negative exponent. We got the 6y minus the 42x. So notice with that 6y minus 42x, and actually maybe I'll just do this now, because I can actually factor a 6 out of that. So if I factor the 6 out, I get y minus 7x. So important that we take a look at that. Since the denominator is not a fraction, I would probably just lean towards working on the numerator. The LCD for the numerator would be x squared y squared. So this one needs the y squared, and this one needs the x squared. And so we end up with, let's see, y squared over x squared y squared minus 49 x squared over x squared y squared. And again, our 6 times the y minus 7x is still there. When we put those together, in the numerator we'd have y squared minus 49x squared over x squared y squared. And then our denominator, the 6 times the y minus 7x. Now the numerator there will factor the y squared minus 49x squared. That is that difference of squares pattern. So that factors as y plus 7x and y minus 7x. And the denominator there is x squared, y squared. Just put a line there to break that apart. And again, what I'm going to do is flip this over, multiply by its reciprocal. So it would end up being 1 over the 6 times the y minus 7x. So again, important to look at that because now the y minus 7x's cancel, and we wind up with a y plus 7x over 6x squared y squared. And again, that's all we can do with that one. So there we go. Again, I did do a couple less of that first type that is on the quiz. That's why your practice quiz is 8 questions. Mine is only 6. But hopefully this was helpful in looking at those different questions. And if you have any further questions or want to go over anything else, just feel free to let me know. Thanks.